Hi guys, welcome to today's question. This is 2019 paper 1 question 9. This question is going to involve some geometry that's really just algebra in disguise, and also some calculus that helps make a relationship between two things. So let's get into the video.
Okay, so here's our question. We're given these Norman windows here, which consist of a rectangle topped by a semicircle. We're told the height of the rectangle is y, and the radius of the semicircle is going to be x, as shown in this diagram, and the perimeter is p. So the first thing we're asked to do is to write p in terms of x, y, and pi. This shouldn't really be too difficult. Okay, so what we have here is y on the left here, and y on the right, and also 2x down here. So that takes up the rectangle part of the perimeter. Now what we need is half of the perimeter of a circle which has a radius x. So here in the log tables we can see that the length of a circle, or the perimeter of a circle, is 2 pi r, because that's the perimeter of a whole circle, and we're only looking for the perimeter of this semicircle. We're going to need pi r, and because r is x, it's just going to be pi x. So therefore the length of this arc is going to be pi x. So that makes our perimeter in terms of x, y, and pi 2x plus 2y plus pi x. So therefore when we add the values of all the sides together, we get 2x plus y plus pi x. So we can just rewrite that instead of having y plus y as 2y, but that is our answer. And for doing this part of the question, you're going to get 5 marks. Next, we're told that in a particular Norman window, the perimeter is p is equal to 12 meters. So we've got to show that y is equal to this fraction here, where x is greater than or equal to 0 and less than or equal to 12 over 2 plus pi, where x is a real number. So now all that we have got to do is, first of all, plug in 12 for our value of p, and then just get y on one side. So here we have our equation. First of all, we're going to take away 2x and pi x from both sides, and next we're just going to divide across by 2 to get y on its own. So here we have our equation that's almost there. The last step is going to be to factorize like terms 2x and pi x, so that we have 2 plus pi inside its own bracket. And we're going to take out the common factor x and write it like this, and then put it all over 2. So there we have it. We've shown that now. That's A part 2, and it's worth 5 marks. Next, we're asked to complete the table on the right. So we're given 2 values of x, and we've got to find 2 values of y. So it is pretty easy to see that if we just plug in 0, all of this is just going to disappear, and we're going to have 12 over 2, which is equal to 6. For the next value of x, we're just going to do some substitution here on the left in our box. So what we have here is 12 minus 2 plus pi multiplied by 12 over 2 plus pi. So times 12 over 2 plus pi. So as we can see, these are just going to cancel because it's the exact same thing. So what we actually have is 12 minus 12 over 2, which is just 0 over 2. So that's just actually equal to 0. And we can put that in our table too. So therefore we've completed our table, and for doing that you're going to get 7 marks. And now we've got to draw the graph of the linear function y is equal to 12 minus 2 plus pi times x all over 2 for x greater than or equal to 0 and less than or equal to 12 over 2 plus pi. So there are basically 2 easy ways to do this. You can use the function mode on your calculator and just let f of x equal to y and then plug in this fraction. But for linear functions, I find it easy to just plug in any 2 values of x that we're looking for. So I think I'm going to plug in 0 and 1 and then just draw a line through those once we get our y values, because it's linear. So when we plug in x is equal to 0, we know that y is equal to 6. So that means our line is going to start here. And actually we don't even need to use 1, because we actually have another x value up here for which we know the y value, and that happens to be 12 over 2 plus pi. So if we go ahead and put 12 over 2 plus pi in our calculator, we can see that as a decimal it's going to be equal to 2.3339. So given that our point is going to lie, we know, on the x-axis somewhere around here. So therefore we have our 2 points, which actually happen to be the x and y intercepts. So we're just going to connect those. So there we have our points plotted. And just note as well that the American scheme did accept anything between 2.25 and 2.5 in your drawing, so it didn't have to be overly accurate. But that's for part 2, and for getting part 2 out, you're going to get 8 marks for a total of 15 going for part B, 1 and 2. So now we're asked to find the slope of the graph y, corrected 2 decimal places, and they also ask us to interpret this in the context of the question. So we're going to get that in a sec, but for the first thing we're going to do is just find the slope of y. So by far the easiest way to go about this is just to get the line y, which we have here, in the form y is equal to mx plus c. So we're just going to divide across the top line by 2 and try and get rid of the fraction, which will give us 6 minus x times 1 plus pi over 2. So if we compare this to our general form for the equation of a line, we can see that whatever the number is that we add on is the y-intercept, which here is 6. And we actually know that's true based on our graph up here, which crosses at 6. So we can definitely say that whatever is multiplied by x, which is everything here, so minus 1 times 1 plus pi over 2, is the slope of the graph. So therefore our slope m is equal to minus 1 times 1 plus pi over 2. But the more difficult part of this, part 3, is to actually write an interpretation. So if we go back to where we found this equation between y and x, it was actually when we were told that p is equal to 12 for a certain window. So what that means is we have a set perimeter within which we are varying y and x. And because m is equal to the rise over the run, or y2 minus y1 over x2 minus x1 in the log tables, if we just write m as a number first of all, that number being minus 2.57, this number actually represents the change in y given a change in x. So for every 1 across you're going to decrease by minus 2.57 in y. And that means in the context of the question, because the radius of the semicircle is x and the height of the rectangle is y, meaning that our interpretation is going to be that for every 1 meter increase in the radius of the semicircle, which makes up part of the window, the height of the rectangle decreases by approximately 2.57 meters. For p is equal to 12 meters, which is a fixed value of p. Although the marking scheme didn't have you include this, it wasn't necessary, but it is true. So the most important part is this sentence up here, and adds context to what we're actually doing here and illustrates that all this work was done in order to find how an increase in the length of one component of the window affects the rest of the window. So that's B part 3. So if we're doing that and writing down an interpretation that made sense, you're going to get 5 marks. So next we're told that the Norman window is shown below. So this diagram down here has a perimeter of 12 meters, and we're given a relationship between x and y. So we're asked to show that the function a of x represents the area of the window in terms of x and pi. So we know that the area of any window is going to be the sum of the area of this rectangle of height y and width 2x, and also this semicircle here, which we know is of radius x. So our area down there is going to be y times 2x, and for the area of a circle is of course pi r squared. So given that x is equal to r, the area of our semicircle is equal to a half pi x squared. So now we've got a nice equation for a, but we've got to give this in terms of x and pi. So basically what we're going to do here is that in the case of a12, we're going to sub in our equation for y so that we have pi and x instead. So there we have now a of 12 in terms of x and pi. So you'd think the question's over, and I would personally just stop here because we have all x and pi terms on the right. But in the marking scheme, they go down and simplify this a bit. So we're going to do that as well, but I don't think they have any right to take any marks off you if you just stopped here. So after we multiply into our bracket, we're going to get 24x minus 2x squared times 2 plus pi in this first fraction, all over 2. And the goal here is going to be to get both fractions over one common denominator, which it's already kind of obvious is going to be 2, and then just to factorize them. So here we have now almost our final answer, just again doing some multiplication into brackets and also bringing this term here over into the same fraction again. So when you add pi x squared to minus 2 pi x squared, you're just going to be left with a minus pi x squared, and then once you factorize that, you're going to get down to this bottom line, which is the final answer they gave in the marking scheme. Once again, if you stopped above at any point in this question, I would say you're grand, but for doing all that, you're going to get 5 marks. So the next thing we've got to do is find a dash x. So we're given a of x, which we're just going to rewrite down in the next part. So there's a of x, and we're just going to divide everything by 2 on the top line to get rid of the fraction. So here we have a of x rewritten. So in order to do the next step, we're just going to look at our terms here and realize that all we have is an x and an x squared. So it's going to be a very simple differentiation, just using our rule for differentiating x to the power of n. Now you probably know this off by heart, but it is in the log tables as well. So if we differentiate 12x, we're just going to get 12. We know that the derivative of x squared is just going to be 2x, and everything inside this bracket is just a constant, it's just a number, so it stays the same. So here we have a dash x, and we're going to notice over here that there's actually a 2 on the top and bottom, so we can get rid of those. So there we have it, and for finding a dash x, you're going to get another 5 marks. Okay, this part of the question asks us to find the relationship between x and y when the area of the window is at its maximum. So basically what they're asking for is for us to have an equation in x and y so that we can say something about the relationship between the height of the rectangle and the radius of the semicircle in relation to each other. So because they give us this word maximum, we're going to have to first of all find a dash x, which is the rate of change of the area, and we had to find that up here in part 2. So there we have a dash x, and to find where the maximum is, we're going to have to let this equal to 0. So now what we can say is that x times pi plus 4 is equal to 12, just adding across by x times pi plus 4. So therefore x is equal to 12 over pi plus 4, which is roughly equal to 1.68. Now there are a couple of ways you can proceed. We know that we're going to need our equation for x and y, which is here, and it's also available many times throughout the question. So one thing you could do is just plug in the approximate value of 1.68 for x and see what value of y that gives you. But I think the clearest way to do this is just to do the substitution with the value 12 over pi plus 4 and then see if it cancels down to something which looks a lot like or resembles anything else in the question. So here we have our value of y, given x is equal to 12 over pi plus 4, so we're just going to simplify this down. So now multiplying every term in the fraction by pi plus 4, just to get rid of this pi plus 4 on the bottom of that fraction, we can now just multiply everything out and see exactly what this does. So we have 12 pi minus 12 pi, and we have 48 minus 24 over 2 pi plus 8. So that is just equal to 24 over 2 pi plus 8. And as dividing every term by 2, we're just going to get 12 over pi plus 4. Now you may be thinking to yourself, okay, have you gone wrong because it's actually the same thing as x is equal to? But that's actually exactly the point, is what they want you to show that the area is at its maximum. So a dash x is equal to 0 when x and y are both equal. So we have x is equal to 12 over pi plus 4 and the same with y. So we're just going to put in a nice little summary that the area is maximum when the height equals the radius. And so we have a relationship, and that's it for part 3. So nothing too tricky there, but it is worth quite a large 15 marks. And that's it for this question. I hope you enjoyed the video. If you did, there's going to be other similar videos in the description, as well as some other helpful resources that you can use if you like. And I'll see you next time.